Hey guys, and welcome to a new video in this computer vision tutorial. In this video here, we're actually going to talk about how we can deploy neural networks with OpenCV. So in the last video, we had a short introduction to the OpenCV DNN module that we're going to use throughout the next couple of videos here in this tutorial. So we're going to actually use the different kind of methods that we went over in the documentation to read in a neural network, and then we can actually pass our images from OpenCV through those neural networks that we have deployed with the DNN module, and then at the end we can actually get the predictions out, draw bounding boxes around the objects that we're detecting in the image frame from a webcam. But first of all, remember to join the Discord server. I'll link to it down in the description here, and you can join the channel here, chat with us about computer vision, deep learning, and so on. You can also become a member of the channel here if you want to support the channel more than you're currently doing by just watching these videos here with a small monthly fee, and everything will go to create more and better quality content here on the channel. So thank you guys. So let's now jump straight into code here, where I'm going to show you how we can actually set up this OpenCV DNN module here in Python, and then we're actually going to open up the different kind of models that we need to deploy with OpenCV's DNN module. We're going to create the model structure or model class object that are stored in the documentation in the last video, and then we're actually going to pass the images through those models that we have then deployed here with OpenCV, and then we can actually get the detections out. And at the end of the video here, I'm going to show you the different kind of detections, and we're going to do actual object detection with different kind of objects that we're tracking around in the image frame. So first of all, here we just need to import CV2 here. So we got import OpenCV module here. Then we also need to import time here, because we're going to actually calculate how long time it actually takes to process our images and to get the different kind of the number of frames per second that we can get by running this neural network here on a GPU and also CPU. So we're both going to use the CPU and GPU in this tutorial here, and I'm going to show you the differences because in the previous videos, we've been installing OpenCV GPU support as well. So if you want to know how you can use OpenCV GPU support, make sure to check those videos out. It's really cool, and we get really nice, efficient algorithms that we can run really fast here with GPU, as we're going to see at the end of the video here. So first of all, here we're just going to load in the Coco classes names here. So if you just open up this file here, we can actually see the different kind of classes that we're going to detect in this video here. So we're going to have some different kind of classes that we can detect. So for example, a person, bicycle, car, motorcycle, bus, train, bench, bird, cat, dog, and so on. So we have all these different kind of classes here from the Coco dataset that our neural network that we're going to deploy in this video here has been trained on. So we can detect all of these different kind of objects here with our webcam in our image frame. We're going to track it around in the image frame as well, and then we're going to calculate the number of frames per second that we both get with the CPU and running our neural network on a GPU. So if we just go into our code here again, we're just going to open up this file here, so we can actually load in each of these individual classes here one by one, so we can then use that later on to actually draw what we're detecting in our image frame. So we're just going to open it up here as F here, and we're going to pass this R here because we're going to read this file, this text file that we're opening up here. And then we're just going to have these class names here, which is just a list with all of these different kind of class names, and we're just going to read in each of the individual classes line by line here and store it in this class names variable here or in this list here. And then we're just going to print the class names here, so we can just see what all of these different kind of classes that we can detect is down in our output. So the next thing here that we're going to set up is just so we can get different colors for each of the individual classes. So when we're going to drag around objects in the image frame, we just want to get a new or another color for the different kind of objects that we're tracking in our image frame. So here we're just going to have this variable colors here. We're just going to take a random number from a uniform distribution here, NumPy. So we're also using NumPy in this video here. So we need to import that up here as well as NP. So we use NumPy to get a random number from a uniform distribution between 0 and 255. And the size here, we just set that equal to the length. So at the number of different kind of classes we have, we set that as the size because we want to get one color assigned to each of the individual classes here from our object detection. Then we set 3 here at the end. So now we can actually load in the deep neural network here that we actually have pre-built. So in this video here, we're going to use the SSD MobileNet version 2. I'm going to put all of these things here in my GitHub, and then you can just download them to your computer, and then you can just access them and pass the path to the models that you actually have in your own program. So in this example here, I just have them in this model here. So I have them in the same directory as my original main file here, or my object detection file here. And then I just have some models here, and then I have the object or the model for the object detection inside of this object folder here. So now we can actually go down here and actually load in our model. So we're going to have our model here, and we set that model here equal to CV2 because we're going to use OpenCV now with the DNN module to actually like be able to load in this DNN model here. And then as we saw in the last video, we're just going to use this function here, read net. So we're actually like just going to use and read in a neural network here from the DNN module in OpenCV. Then first of all here we need to specify the model here that we're going to use. So the path to the model that we're going to use. And as we can see here, I actually have them inside of my models and then object, and then we are going to import this frozen inference here. So here we're just going to set the model here equal to models, and then we go inside the object folder, and then here we have this frozen inference graph, because we need the different kind of like first of all we need to specify where our weights is actually like stored for our neural network. So the next thing here that we're going to specify is the actual like config file for our neural network. So the actual like architecture of our neural network. And if we go in here, we're just going to specify the config here again. And we have the config file inside of models, and then we're going to object. And then inside of object, we need to specify this SSD mobile net here. So if I just open up the file here, we can actually like see the whole architecture here of a neural network that we're going to load in. So I'm just going up here instead here, and I'm just going to copy paste this whole name in here to the actual like config file path. So I'll just copy paste this here, and we're going to the object file here again. And then at the end here, we're just going to specify the file here. So now we actually like both have our model file, and we actually have our config file here as well. So the last parameter here that we need to specify is the framework that we have actually like trained our model on. So we just have framework here at the end. And then we set the framework here equal to TensorFlow, because this model here has been trained with TensorFlow, and this is the format for the different kind of text files here that TensorFlow uses. So we have TensorFlow here. TensorFlow here specified as the framework here, and then we can just end it here with this parenthesis here. So now we have like set everything up for a model here. We have loaded in our model by using this readNet function here, or like method from the DNN module. We specify the model file with all the weights and the config file with the architecture, and then we specify the framework that we have used to actually like train this neural network here. So now we have actually like loaded in our DNN module with only this line of code here by just specifying the paths of these different kind of models, or like the neural network that we want to load in. Then we can actually like go down here and set the backend and the target to CUDA, so we actually like be able to use GPU to do the inference here in DNN and OpenCV, because we can only use the DNN module in OpenCV here to do inference. We can't do any training or anything like that, but it's really good for deploying neural networks with OpenCV. We could do other different kind of operations with our images before we pass them to our neural networks and stuff like that. So it's really useful to use OpenCV and then deploy your models with OpenCV as well, so we combine everything together. So down here we can actually just take the model here that we are now loaded in, and then we can set the preferable here. So we have this preferable backend here, and then we set this preferable backend here to CV2. So we're going to add the DNN module in OpenCV, and then we actually just specify we use this DNN underscore backend, and then we're going to use CUDA here as the backend for our model here in this example. So we can do the exact same thing here, but instead of the backend here, we set the target as well. So we're just going in here, and then we just set the target here as well instead of the backend. And at the end here, instead of DNN underscore backend, we're just going to specify target here. And at the end here, we need to specify CUDA as well. And if we don't set the backend and the target here to CUDA, it will actually just use the CPU as default. So we're going to use this later on, and I'll show you if we try to comment these two lines out here to see what the performance actually like does by using a TPU instead of a CPU when we're running our neural network inference. So now we have actually like set everything up here, and we can then go down here in our while loop. So here we're just opening up the webcam. So we have this cap variable here. We set that equal to cv2.video capture and then the 0th element. So we're just going to use the webcam that is connected to my computer in this example, and then we're going to use this capture here later on to actually like read in the images individual from one by one from the webcam. So down here we can just, while the webcam here is open, then we can go down here and read in the image first of all. So we're just going to have a success variable here if we're actually able to read in our image. Then we're going to have the actual image here in this variable, and then we're just going to specify here cap.read. So now we can actually just with this line of code, we can just read in the image from a webcam and store it in this image variable here that we can then use later on to actually like pass it through a neural network. But before we're passing it through a neural network here, we also need to create a blob of image. But first of all here, we need to specify the image height here, and we also need the image width. And then we also need the channels here at the end when we're actually going to take the shape shape of our image. So we're going to set this equal here to image.shape. So now we actually both have the image height, the image width, and also the channel for our images that we're then going to use later on to actually like draw our detections. Now we can create a blob here from the image because we need to create this blob here to pass it through our neural network in the next line of code. So here we're just going to set this blob here equal to CV2. So we're going to use the DNN module here again. As I showed you, we have this blob from image here, method here from OpenCV's DNN module that I showed you in the last video, where we went through the documentation of the DNN module. So here we're just going to specify the image that we want to create a blob from, and then we also need to specify here the size of our image. So in this example here, we just have a 300 by 300 image here that we're going to use, and then we also need to specify here the mean value for each of the individual channels that we need to subtract from our like images when we're creating this blob here before we're passing it through our neural network. So we just have some arbitrary values here, which is the means for each of the individual channels of our image. And then at the end here, we also need to specify something called swap RB, and we set that equal to true here as well here, because then we're going to use BGR instead of RGB, because OpenCV is using BGR as the image color space instead of RGB. So now we actually have the blob of our image here, and then we can go down here, start our timer. We have created this blob here, and then we're going to time how long it takes to actually do this processing or passing our image through our neural network. So down here we can set our input to the actual model here. So we're just going to have this model.input set input. And then we're going to pass in this blob here that we just created from the image up here. So this will be the input to our model. And then we can go down here and actually make the forward pass in our model with this input that we just set up here in this line of code. And then we're going to go down here and set output, which will be the actual detections from our images, or all the different kind of objects that we're detecting in the images. We're going to store it in this output variable, or this output variable here. So we have this here, and then we can say model here, model.forward, and this will actually just do a forward pass of the blob of image here through our neural network. Then we'll get all the predictions, all the different kind of detections stored in this output variable. So now we're actually set everything up here. We can end the timer. So we both start a timer here before we're passing our image through our neural network, and then we're ending the timer afterwards to actually see how long it takes to process this image here in our neural network. So down here we can just calculate the FPS here for the current frame detection. So the number of frames per second will just be 1 divided by the end time minus the starting time, and now we actually have the number of frames per second that it took to actually run this neural network here, or do a forward pass in our neural network, both with the CPU and the GPU. So now we actually have all the detections in one image here, or one frame from our webcam that we loaded in this output variable here. So now we can just go down here and create a folder where we're running through all of these different kind of detections, or all of the output detections that we have from our image. So we're going to have this folder here that we run inside of this output variable that we got up here from the model forward pass. And then we're going to take the 0th element here and the 0th element here. So this is just a basic data structure for the output variable that we get from our model. So we can go into the documentation here and read more about what this data structure here actually is. But we're just going to take all the third elements here, or the 4th element. Then we're just going to take all of the values that we have inside of that to actually get our detection from the object that we're detecting in the image frame. So now we have this folder here that is running through all the detections in our image. Then first of all here we need to set up a confidence score. So we want to get the confidence score, how confident we are that we're detecting a certain object in our image frame. So we're going to set that equal to detection, and then we take the second element in our detections, which will be our confidence score of a certain object. So now we both have the confidence here, and then we can go down here and say that if the confidence is higher, if it's higher than some threshold, then we actually want to draw and use that detection in our image frame, because then we're certain that we actually detected this object here, and then we can play around with a minimum confidence score threshold to see if we can reduce some of the false positives and stuff like that in our image. So we have this if statement here, and if the confidence is greater than some minimum confidence score here. And then we're going to up here, and then we actually want to set the minimum confidence score here to something. So we just go out of the while loop here, and then we can go up here and set the actual minimum confidence score, and in the start we just set that equal to 0. Let's say just 0.4 in this example here, and then later on, if we get a lot of false positives and stuff like that, we can just play around with this minimum confidence score threshold. So now we can go down here again. If the confidence score is greater than the minimum confidence score that we just set up, then we're actually going to do all of these different kind of detections here. So first of all, if we have a detection and if it's higher than some threshold, we're going to get a class ID, because we want to know what class are we actually detecting in our image frame. And then we're going to take the first elements of our detections, which will be the class ID that we're detecting in our image frame. Now we have our class ID, then we can go down and get the actual class name, and we get the class name here inside of our class names list that we got from loading all in all the different kind of Coco classes in the start of the program here, where we opened up the text file, and then we read in each of the individual rows in that text file to the class names here. Then we're just going to take the integer number of our class ID just to make sure that it is an integer, because we're accessing like an index in this class names list here. And then we're just going to take the -1 here to actually like get the real class name that we want. So now when we have this one here, we also set up the different kind of colors for detections. So we need to set up a color here for a specific detection in our image. Then we're just going to take the colors here, and then again we're just going to take the integer of our class ID in this example here again. So now we have both a class name and we have a color assigned to that specific class name or class ID that we're detecting in our image frame. So when we have that, we can actually like go in and get the boundary boxes now and draw the actual bounding boxes with the confidence score and also the class name or like class ID on top of that bounding box for each of the individual detections that we're doing in our image frame. So we're going to create this bounding box here for our X value, and then we're going to set that equal to detection. And then inside our detection here, we're going to take the third element, which will be the bounding box for the X coordinate. And then we're going to multiply that with the image width that we got from the top of our program here as well. We're going to do the exact same thing here for the Y variable. So I'm just going to copy paste this here. We're going to change this X here to Y, and the detections here, it will be the fourth element. And then instead of the image width here, it will be the image height that we're actually like scaling our values to. So these are the bounding box coordinates. And now when we have the bounding box coordinates, we also need to get the bounding box width and height, because we're taking the top left corner of our bounding box, and then we need to actually like specify where we will actually like want to draw a bounding box. So we also need to draw like the box around that point. So we need the image width and height as well. So then we're going to go down here and actually create this bounding box here for the width. And then we're going to set that equal to detection. And then now we're going to take the fifth element of the detection. So these are just the individual like indexes in the detections that we're running through. So there's one individual index that we're one individual detection in our for loop that we're running through that we've detected in our image frame. And then we take all of these different kind of indexes to both get the image width, the coordinates for X, Y, so we can actually like draw these bounding boxes here. So now we're going to take the fifth element, and then again we're going to multiply that by the image width in the example here. We're going to do the same thing here for for the height of the box. So I'm just going to type this out here, and then it will be the sixth element here in our detection. So now we have actually like the bounding box here for detection in our image frame. So now we can just go down here and use the rectangle function from OpenCV to actually like draw these different kind of coordinates and also the width and the height of our bounding box. So then we can go down here and we can just say cv2.rectangle as we're used in all the other different kind of different kind of videos that we've been through, where we're drawing bounding boxes around objects that we're detecting. So we have this cv2.rectangle, and then we need to specify the image where we actually want to draw a rectangle, and then we need to take the integer value of our bounding box here for our and the first one here is our X value, and then we also need to do the same thing here for the integer value of our bounding box Y value. So now we've specified the top corner here, so I just need another B here. So we have the bounding box X coordinate and the Y coordinate as well. So I also need to specify the width here, so it will be the integer value here. So we're just going to take the integer here, and then we're going to take it off the bounding box here for the height. And then we also need to specify it for the width here as well. So we actually like need to specify the width before the height in this example here. So I'm just going here and we're going to create this one here. We're going to take the integer value of the bounding box here for the width to start with, and then we take the height as the second one here. So now we're actually set everything up here. We'll just make sure that all the parameters here matches. So the last two parameters here that we need to specify is the actual color that we want to draw the bounding box with. So we're just going to specify the color, and then at the end here we also need to specify the thickness of our bounding box that we want to draw. So in this example here, we're just going to have a thickness of 2 for our bounding box. So now we have actually drawn the bounding box with this rectangle function here from OpenCV. And then we can just go down here and actually specify the put text as well. So we're going to put the text of the class name on top of that bounding box here, and I'm just going to type it out here. So now we just have this one out here with the put text. So we just specify the image here that we want to actually put the text on, and then we're going to specify the class name here. So the class name of the class that we're actually detecting in the image frame, and the class that we're actually drawing the bounding box around here with this rectangle function or method here from OpenCV. Then we're just going to specify the coordinate here where we actually want to draw put that text. So we're just going to put it on top of our bounding box, and that's why we take the bounding box y value, and then we minus that, also subtract that with 5. So we just put it on top of that bounding box instead of right on top of it. Then we're just going to specify here the font that we're going to use, and the thickness, and also the color here of our text that we're going to put on top of our rectangle, and we're just going to put the same color as the bounding box itself. So now we have actually set everything up here, and then at the end of the program here, we're just going to put the text here of the FPS here as well. And then at the end, we're going to show the image here where we're actually doing all the different kind of detections. And on this image here, we're drawing both all the detections and also the class names of all the individual objects that we're tracking around in the image frame. Then down here, we just have a wait key here. So we're waiting if we press Q. If we press Q, we'll just break out this program here. We will release our webcam, and we will store all the windows here in OpenCV, and our program will then terminate. So now we have everything set up here, and we can just go up here, hit the green button here, and we can then run the program. First of all, here we just print out all of the different kind of class names that we got from the file that we loaded in as well. And then we can see here, we got the image frame here. We get a person here that we're tracking around in image frame. We're drawing the bounding box here, and also the corresponding class name and above of the bounding box here. And we can see that the bounding box here, or this algorithm here, is actually tracking the person here around really good in the image frame. We can see here up at the top, we get around 90 to 100 FPS. And this is because we're running our neural network on a GPU instead of our CPU. In 1 second here, I'm going to run it on a CPU, and then we can see the difference in the performance here when we're running our neural networks here on a CPU compared to a GPU, which is really, really fast when we're doing a deployment and inference with neural networks. So we can also see some other different kind of objects here. If I, for example, take this glass here, it will just say that this is a cup, and it can track it fairly good around here in the image frame. If we want to have some other different kind of detections, we can lower either we can lower the threshold, or if we get a lot of false positives, we can then set the threshold higher, so we get more less false positives. If I move away here, we can actually see that it detects this TV here in the background as well. It tracks really good and really nice around here in the image frame, and we can do the same thing for a lot of other different kind of objects as well. So now I actually lower the threshold here a bit, and we can see that if I move away here, it actually detects a chair behind me as well here, and it also still detects the TV here at the background. So we can get some more different kind of detections that is less certain about if we're lowering this, if this minimum confidence score here, if we're lowering that threshold. But if we get a lot of different kind of false positives, we need to set that threshold higher again, so we get a nice and more smooth tracking around in image frames of the individual objects that we're actually detecting. And as we can see here, that down here, we can actually detect all of these different kind of objects at the same time in our image frame. We can just have this really fast and efficient neural network here running on our GPU, detecting all of these different kind of things here in the same image frame. We can draw all the bounding boxes, all the labels, we can even draw the confidence score here on top of the bounding box here as well. So I'm going to create another video where we're going to play around more with these different kind of things. So in this video here, we just went through how we can actually set it up line by line in the code. And then in other videos, we're going to play more around with what we can actually like do with these detections in the image frame here. So the last thing here that I want to show is just if we're not using the GPU here to actually like do the forward pass of our neural network. So if I just comment these ones out here, these two lines where we set the preferable backend and the preferable target here to CUDA, then we are actually using the CPU to do the actual detection instead. So if I just run the program here again, it will not use the GPU, but the CPU in this example here. So now we can see that the image here, it gets a little bit, a bit more blurry here. We can see we only get like around like 30, maybe 35 FPS here in our image frame when we're only detecting one person. If we're detecting more objects, like we will just lower the FPS even more. And we can see here that it still detects that this is a cop. It doesn't track it as good around. We also get some false positives here, as you can see. Sometimes it actually like detects that this is a cell phone. It's not really tracking the objects around that good as compared to when we're running it on a GPU. And that really makes sense and it's really intuitive that GPU is just way better. So if you have a GPU available and you want to know like how you can set this up here with GPU, really make sure to check that video out where I set up OpenCV with GPU support both for C++ and Python, and I even show you how we can set it up here in Visual Studio Code, Visual Code, and so on. So it's really efficient when using the GPU, as we can see here, and this is just like a standard example where we're running object detection of a different kind of objects, and then we're comparing it with the CPU, GPU, and the GPU is up to 3 times faster. It just tracks the objects around here better in the image frame. We get more and better accurate and precise predictions with our neural network. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video here, and also like this video here if you like the content and you want more of it in the future. So I'm currently also doing this computer vision tutorial where we go over the basic stuff about image operations. I also have another video, deep learning tutorial where we're going over the basic stuff about the neural networks, how we can create neural networks from scratch, training on a data set, and then do predictions on images and data that the neural network hadn't seen before. And now we're actually like both combining computer vision and deep learning as we've been through by using this OpenCV DNN module. We're both going to use it with CUDA, so we use OpenCV with CUDA GPU. So then the upcoming videos and in the upcoming tutorials here in this channel, I'm really excited for those because it's really nice that we can both combine computer vision, deep learning, and get these really fast and efficient neural networks here running to do actual object detections that we can use for a lot of different kind of real life applications. So I'll link to one of the tutorials up here, or else I'll just see you next video, guys. Bye for now.